All right, we're going to do 7-4. This is a big deal lesson. There's some lessons that are, I mean, it's good to learn. But this is one of the big deal lessons, okay? When I think of geometry, I think about doing a lesson like this, okay? This is the kind of stuff that's really going to help you when you take the SAT, all right? It's been a long time since I've actually looked at the SAT, but from what I remember, I used to teach a couple classes years ago on preparing, for the math part of the SAT, and there's quite a few of this stuff on here, okay? So if you know how to do this stuff right here, it's going to help you with several problems on the SAT, all right? You could, and it'll help you do things a lot faster, a lot more. Is it more quick? A quick. How would you say? Would you say quicker? Do it quicker, or more quickly? Is more quickly right? I don't know. So anyway, yeah, do it quicker. So anyway, let's talk about it. So these are two types of right triangles. All right. Remember, they're not just any old triangle. They're right triangles, and they are special, very special. So here we go. Here's one. Now watch this. I'll tell you what, I'm just going to eyeball it. I'm not going to get real picky to make it perfect. What I'm trying to do is make these two sides exactly the same. Does that look about exactly the same? It's pretty close. It might be a little bit, but let's use our imagination. Okay? So, well, it's not equiangular. Okay? It's isosceles. Okay, but we're not going to call it an isosceles triangle when we refer to it as a special right triangle. Okay, it is isosceles because two of the sides are equal. So what I want us to do is not look at necessarily the sides. I want to look at the angles. Okay, because these special right triangles have to deal with the angles of the triangle. Well, we know one angle right now. That's a 90-degree angle, right? Because it's a right triangle. Do you agree? Now, if these two sides are equal to each other, we should be able to figure out what this side and this side are. This angle and this angle are 45. That's right. Because remember, they all add up to 180, right? You already got a 90, so these two have to add up to 90. And what must be true about these two? They got to be equal, because if you have an isosceles triangle, the sides opposite, right? The sides opposite the equal angles are equal. Or sorry, say it the other way around. The angles that are opposite the equal sides must be equal to each other. We had a theorem way back that said that. You can look that up if you want. So these two would be equal to each other, and that's true. And then we know, just by knowing that these two sides were equal, we know both of them are 45 degrees. All right? So our first special triangle, we're going to call a 45, 45, 90 triangle. Some people might call it 45-45 right triangle. It's fine. But in the book, they say 45-45-90 triangle. Okay? Now, what I'm going to do, I could just sit here and just show you the relationships between them. Okay? But I'm going to show you why. Especially the first ones. It's not hard to figure out. So, yeah, I'm just going to jump to this. So let's use the letters that I used in my notes. We'll call this triangle ABC. All right. So normally what we would do, if I call this angle A, what would I call this side down here? The side.
Side CB.
I could say CB, that's true. But to make it a little easier, if I call this angle A, this is across from angle A, so I'll call it side A. Is that all right? And so we can just use a, instead of saying CB, which you could say, you wouldn't be wrong, but it's a lot easier for what we're going to do now, just to use one letter instead of CB. Would you agree? All right, so it's a lot easier calling this side A than calling it side CB. So what do you think you'd call this side right here?
B.
This would be B. It'd be lowercase b, and what would this side right here be?
D. Why is it lowercase?
Because a side is lowercase. Because when we just use one letter, listen, when we use just one letter to represent a side, we use a lowercase letter for that, okay? Now, I could call this capital AC, right? I could call this capital CB. It's just easier when you're doing what we're going to do here in a second, just to call it side A, side B. What do you think we're going to call this side right here?
C.
Side C, because it's opposite angle C. Everybody with me on that? Okay. Well, we did Pythagorean theorem, right?
Yeah, like where the angles were like opposite sides.
Yeah, we've done
And we
this.
had to do like the lowest and greatest opposite numbers.
Yeah, we did. So we've done this before. It's not that big of a deal. But let's do this. Since I know that this side and this side are equal to each other, since I know that this side and this side are exactly the same, let's not call one A and call one B. Let's just call them the same exact thing, right? So what we're going to do is this. We're just going to call it the same letter. Now, I could call them both A if I wanted to, or I could call them both B if I wanted to. But a lot of times they'll do this. Let's just call it X. I'm trying to make like a little, make it look like a lowercase x. So I got to put a little curly Q on that, just to kind of make it look like it's cursive or something. So let's just call it X. So now watch this. What I want to do is I want to find the relationship between the hypotenuse and the other two sides. You hear what I just said?
Yeah.
It's really important. I want to find the relationship between the hypotenuse and the other two sides. For instance, is the hypotenuse like twice as big as this side? Is it 3 times as big? Is it half as big? Is it some other number times as big? Okay? That's what I mean by let's find the relationship between them. Because there is a relationship between the hypotenuse and the two legs.
That's just too big of it.
2/3?
No.
Okay. Anybody else have any other guesses?
1/3.
It's probably something that you would never guess. All right? But let's figure it out. So what we're going to do is we're going to use Pythagorean theorem like we said before. And let's come up with a relationship between the hypotenuse and the legs, okay? So if we're going to use Pythagorean theorem, what would we do? I would take what? X, come on, it's Pythagorean theorem.
Square.
X squared, thank you, plus
X
squared equals what?
C squared.
C squared. Now why did I make them both X? Because they're both exactly the same. That's why I didn't put an A here and a B here, right? They're exactly the same. So I called them both. You could have called it A squared plus A squared equals C squared. Doesn't matter. I just happen to use X. Now, let's simplify this. What we're going to do is we are going to solve for C. We're going to solve for C, all right? So 1x squared plus 1x squared is 2x squared. Now, again, what are we doing? We're trying to solve for what? C. I want to solve for C. So what would I do to get C by itself here?
Square root.
Square root it. Very good. So I square root this side, and I square root this side. Let's flip them around. Let's put the C on the left. Is that all right? Just put this over here. So now, how do I simplify this?
X.
Well, what happens to this? Let's forget the 2 right now. Let's do the easy part. Actually, the 2's kind of easy, but what's the square root of x squared? What does that x? What does that square root do to that square? Cancels it out, right? So what am I going to have? I'm going to have.
2x.
It's not going to be 2x because that 2 is still under a square root.
So X.
Yeah, but what happened to the 2?
squared?
Does it go away?
It's 1.
No, it's not
Wait,
1.
wait.
Why is it 1?
What?
It's not 2 squared.
It's the square root of 2.
It's the square root of 2. Okay, look, it's still under a square root, isn't it?
Oh, so it's still.
Okay. See, it's still under a square root. I can't simplify it, right? So, I just write the square root of 2x. That's it. See, that x squared, and I took the square root of that x squared, it became an x. I took the square root of 2. Well, I can't do anything with that. It doesn't simplify, right? So I just keep it the square root of 2. We good with that? You'll be doing a ton of that in Algebra 2 next year. All right, so be ready
So a
for
lot
it.
of calculators say if it can't go anywhere.
There are some calculators now that will write it as the square root of 2. But like if you had a little scientific calculator that's not the big graphing calculator, it won't do that, I don't think. Square root of 2 is like 1.141 something, I think. Put it in there. What is it? Square root of 2. It's like is it 1.4414? Right, that's what it is. 1.414 blah, 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 right? So it's not quite 1.5, is it? Right? So what does this mean? What does this tell us right here? This tells us that the hypotenuse, write this down.
It's 2 times.
It's not 2. It's not a 2.
Is that it? No, it's not.
That doesn't look like a 2.
Square root of 2x.
It's the square root of 2. So the hypotenuse, which is C, is the square root of 2 times what?
1x.
Yeah, and what do we call that generally? If I call this the hypotenuse, what do I call
Leg.
these? The legs, okay? So the hypotenuse is the square root of 2 times one of the legs. You say, well, which leg? Well, if it's a 45, 45, 90 triangle, both
It don't
legs
matter.
are the same, so it doesn't matter. Everybody see that? So that's, now, are you going to have to do that on a test? Not necessarily.
Oh,
But we did it so that we could see where this little formula comes from. I could have just sat here and said, okay, see that hypotenuse right there? It's the square root of 2 times this leg. And we would have been done with it. All right? And you're probably thinking, well, why didn't you just do that? Well, I think it's good to see where it came from. I didn't just pluck square root of 2 out of the sky. Okay? But this is where it comes from. It comes from the Pythagorean theorem. We good with that? So here's an example. Yeah, let's do this. So, yeah, I'm just going to draw that same triangle. In the example in the book, if you look in the book, they kind of like turn it over a little bit, flip it, but it's the same thing. All right, so this only works when it's what kind of a triangle? This hypotenuse equals square root of 2 times one of the legs. What kind of triangle does it have to be for this to work? What is it? Okay, an isosceles, or a, what do we call?
special right triangle.
Yeah, but what kind of special right triangle? It's right here.
45,
So 45, 40. That's how we're going to refer to it. Okay, you could refer to it as isosceles, but we're going to refer to it in this lesson anyway as a 45, 45, 90 triangle. Okay, because we're going to do another one that's not 45, 90, and it's not isosceles. So I want to refer to it with the angles. So what if this is 45? What if this is 45? Okay, and they told you that this side right here was 3 centimeters. And you want to find the other two sides. Okay, so I want to find this side right here. I want to find this side right here. Really, listen, you don't really have to do any arithmetic or any math at all. You should just be able to look at it and write down the answer. There's really no work to show. So first of all, let's find this side down here. This is the easiest one. What's this going to be? This one down here. Yeah, it's going to be 3, because if it's 45, 45, then these two legs are exactly the same. Everybody with me? Okay, so if this is 3, this is 3. And they put units in here, so let's put the units with it. Now, what's this going to be right here?
Square root of 2 times 3 centimeters.
Okay, so how do we write the square root of 2 times 3? We usually would write it like this. We'd put the 3 first, and then we put the square root of 2. And then we put... No, there's really no simplifying to it. It's not 6. You can't go 3 times 6 because this 2, it's not a 2. It's a square root of 2. What is the square root of 2? We said it earlier. It's around 1.414 blah, 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 or whatever it was, okay? So this is not a 2. It's the square root of 2, which is a completely different number. Would you agree? 1.4 and change is a lot different than just a 2. So this is how you would write the answer. Now, this book, I think, writes it both ways. Okay, I think they do it as a decimal, and they do it like this. My preference, and most of the books that I've probably taught out of maybe 3 different geometry books, and most books just usually keep it like this. Actually, I should have circled the centimeters there. So this is how I would prefer that you keep it, okay? This right here is an exact answer. If I put it into a calculator, remember what square root of 2 is. It's 1 point, what is it again? Is it 1.4? Okay, 4, or it's 1.414 blah, 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 whatever it is, okay? And it keeps on going forever and ever. Was it in this class I talked about irrational numbers yesterday? Okay. So square root of 2 is an irrational number. It keeps on going forever. So I can't keep putting decimal, forever, so I got to round it. So usually they'll tell you where to round it, but if they don't tell you where to round it, usually we'd round it to maybe 1, maybe 2 decimal places. Okay, it really depends on what they give you right here. Sometimes they might put, like, instead of 3, they might put it like 3.0. So how would I round this answer when I put it in a calculator? If this has 1 decimal, then I would round this to what? 1 decimal. You see that? It's just a general rule of thumb, right? Somebody do this for me. Do you know how to do this on your calculator? You should try it. You should try it, okay? I'll do it in my calculator just to see. Actually, did I write it down? Yeah, I did. Yeah, it says it in the book too. Yeah, it's approximately 4.2. Remember we said the squiggly equal sign is approximately, and then 4.2 centimeters. Why do I put the squiggly? Why approximate?
It's approximate.
Because
It's not exact.
it's not exact. We rounded it to this, didn't we? Okay, I don't know what was the decimal after the 2, or was there?
3.
So what was it? 4 point what?
4.24.
4.24. Okay, everybody knows how to round, right? Hopefully, the 4 means you just keep that number right there. The 2 the same. All right, we're not going to go through that. So that's pretty easy. What if they did this though? What if you could put the 3 first if you wanted to. What calculator do you have? Do you have one? Okay, you should always have one on. Listen, in high school, you should always have a calculator with you. Now, I know you have your phone, but you're not allowed to use your phone. But I am, so I'm going to use my phone. So I actually have a scientific calculator. See that? It's an app. You just go to the store and put scientific calculator. It's free. You know, every once in a while they ask you to update it or something, and you say no. You don't have to buy it. But this is a scientific calculator. You can have it. So at home, if you don't have a calculator, put it on your phone. Now in here, we're not going to let you use your phone, right? So, but anyway, that's what it looks like. Okay. So what I would do, you could do it a couple ways. If you wanted to do it just like this, you would hit 3. Does anybody have one on them?
Yeah.
Okay. Now again, it depends on your calculator. They make calculators so different now that a lot of times it all depends on your calculator. But you have to know how your calculator works. So I would try this. Okay, I would try it right now because there are times when you need the decimal answer, right? So you'll need to know how to put it in the calculator. What I would do is I put 3, then I hit times. Now on my calculator, I don't hit the square root first because you know what's going to happen? It's going to take the square root of 3. If I hit 3 and then square root, it's taking the square root of 3. I got half of you listening.
Mine says syntax error.
Okay, I know. That's what I'm saying. So it all depends on your calculator. So I hit 3, then I hit times, then I hit 2, and then I hit the square root button. There's a button on the calculator that says square root, and it gives me the square root of 2. But then when I hit equals, then it'll do the multiplication. And so it's 4.242640687. Keeps on going, right? If I had a bigger screen, it would keep on going. But it would. It keeps on going forever. But it never repeats. Remember I said that? It never, like once in a while, it may repeat a number. Right here, it doesn't. But maybe way down the line, it'll repeat a number, but it doesn't keep repeating the same number over and over again, all right? We call that an irrational number, okay? Irrational number. All right, enough of that. Learn how to do it on your calculator, okay? Work it out. I can't go through everybody. There's probably like 3 or 4 different ways, depending on your calculator, that you could put this in, all right? Some people might want to put the square root of 2. Oh, you know what? I actually have a calculator on here. I almost forgot. Have you ever seen my calculator?
No.
Look at that. I think on YouTube, I don't. Let me go to my. Yeah, on YouTube, you can't see it, but if I click this. Well, I thought if I clicked it. For some reason, it's not showing up. That's okay. Well, it looks like it should be here. It's not showing up on YouTube, but that's okay. It's no big deal. So, first of all, I'll clear it. No, for some reason I can't use the pen when I do this calculator. It's so weird. So, what is 3 squared of 2, correct? So on this calculator, you can just hit 3, then you can hit the square root. Now the square root, I know it's kind of small, but it's right here. It's like on the screen itself, and it's yellow. So what are you going to have to do? You're going to hit the second function. I think I hit second. Did I hit it? Yeah, there's second function. Then you hit this. There's the square root. Then you put a 2. Now, you don't really have to close the parentheses. I'm kind of OCD about it. I like to close the parentheses, make it look a little nicer, and then hit enter. Then there it is. Okay? So that's how you would do it on this type of calculator. Now, some of your calculators have like a wider, bigger screen. That's probably how you do it. Okay? Even if it's not a graphing calculator. But what you could do, well, actually this calculator doesn't do it backwards. This is the way this calculator does it. But just make sure you know how to do it on your calculator. Everybody good with that? All right. That's all I'll say about calculators. Let me get rid of this. Okay. Let's go to the other. I only got 10 minutes. I took way too long on this. So let's do the other triangle. I'm going to try. Again, this is not going to be perfect. This isn't going to be perfect, but it's close enough. Okay, and then right here. All right, this is another special triangle. Now this time, this is another special triangle. This one is 30 degrees. So if I told you one of the angles, what would this angle up here be? Be 60 degrees. Okay, so guess what? We just take a wild guess what we call this triangle.
45, 45.
Why would we say 45?
I meant 30, 60.
Okay, it's 30, 60, what?
And then
90 triangle. Okay, now
This is
let me think for a second here. I hate to do this, but I'm not gonna, just because of time. I just don't have enough time to go through why. Okay, yeah, I'm sure you're heartbroken. I'm just going to show you the relationships, okay? Now watch. This is still, I'm going to call this the hypotenuse. Now these two legs are not the same now, are they? Because it's not a 45-45. So this one is shorter. And Anthony alluded to this earlier. He said that the side opposite the smaller angle was smaller. Remember that? Remember we did a lesson on that? That the side opposite the smaller angle, right, was smaller than the side opposite the bigger angle. Yeah. So this, we're going to call this the short leg, and we're going to call this the long leg. This is the hypotenuse. Remember, the hypotenuse is always the longest side of the triangle. You hear what I said? I had like 5 of you talking at the same time. The hypotenuse is always the longest side of the triangle. But this is the longer what? Leg. Okay? This is the longer leg. This is the shorter leg. I'll just say long and short for this. That's very important that you understand that. Notice the short one is opposite the 30-degree angle. The long leg is opposite the what? 60-degree angle. The hypotenuse is always opposite the right angle, the 90-degree angle. Okay? Now, let me give you a couple... what word did I say? Relationship. I forget the easiest words now. Something happens when you get old. Now, what's going to happen is this. There's a relationship between the long leg and the short leg. So everything, both of these things, refer to the short leg. If you can understand that part, it's easy to remember this, okay? So the hypotenuse is so much of the short leg. It's so many times bigger than the short leg. The longer leg is so many times bigger than the short leg, right? Let's do the easiest one first, which is the hypotenuse. The hypotenuse is exactly, now I don't know, I just eyeballed this, so I'm not sure exactly, but the hypotenuse is twice as big as the short leg. It's exactly double it. So it's 2 times the short leg. I'm just going to write the word short right there. So that's pretty easy. So what if the short leg was 5? What's the hypotenuse? It's 10. What if the hypotenuse was 20? What's the short leg?
10.
It's 10. Okay? If the hypotenuse was 20. Okay? If the hypotenuse was 20, the short leg is going to be half of the hypotenuse. Agreed? Now, there's another relationship between the long leg and the short leg. So the long leg, now this is something you'd probably never guess, but there is a way to show why it's true. Again, I'm running short on time, so I'm just going to show it to you. Maybe another day I'll show you why. It's the square root of 3 times the short leg. It's kind of weird. You're like, where did that come from? Well, I've got it in my notes. I could show you, okay, why it is. It's right there. But again, due to time, we're not going to talk about that. So we'll do this and we'll do an example. And then I think I got one more thing to talk about after that. Okay? So let's do an example. Okay? Again, I'm just eyeballing this. We'll just make it look just like the other one did. And then right there. Okay? And we know that's a right angle. We know that's 30. So, of course, that's going to be 60. Or if I knew that was 60, I could figure out that was 30. Okay? So we'll call this X. And we'll call this one 12. They made this super easy for you. I should have come up with one that's a little tougher, but that's it. You know what? I should. After this, I'm going to show you a little bit of a tougher example. I still got 6 minutes, so it should be good. So now let's find the short leg and let's find the hypotenuse. We'll call it H for hypotenuse. Okay. So what did they tell you? Actually, on this one,
Two times,
yeah. So let's write it down. The hypotenuse is
two times,
twice the short leg, right?
Yep.
Is that going to help us solve for the hypotenuse or solve for the short leg?
No.
not like
Why
that.
not?
It's a 5.
Why not? Why not?
We can find the short leg.
Because I don't know either one of these, right?
Yeah.
So if I can't just go straight and find the hypotenuse because I don't know the short leg. So the important thing to find is the what?
Short
It's the short leg. But I do know what?
the long
I do know the
The
longer leg.
long leg is short
Okay.
3 times.
So the long leg is the square root of 3 times the short leg.
So square root of 3 times x.
So let's write it down. So the long leg is what? 12, right? Is equal to the square root of 3 times the short leg. We don't know the short leg. It's x.
Yeah.
So now what do we have to do? We have to solve,
Get x by itself.
get x by itself. So how do we do that? No.
Wait,
Square root,
divide?
Divide by what?
X. Oh no. Square
X is already up here on the top. What's with the x that I want to get rid of?
square root, yeah.
Square root of 3. So how do I get rid of the square root of 3? I divide by the square root of 3 because that's what I'm trying to get rid of. Agreed?
Yep.
It's a little different, okay? This is a little upper algebra 1 stuff, okay? So if I do that to that side, what do I have to do here? I got to do it to the other side. Now, I don't know if you remember, I don't know if you were taught this in algebra 1, but listen, I think we may have done this once in here. I don't remember if we did or not. But anyway, we don't want to leave our answer like this. Why don't we? Because you should have learned this in algebra 1, but they don't want you to have a square root in the denominator, okay? There's reasons for it, but just know that mathematicians don't want square roots in the denominator. So what we're going to do is we're going to do something. I'll show you this right now. This may be brand new to you, okay? So watch and write it down. The way we get rid of this square root is to multiply it by itself, because the square root, let's say this, the square root of 4 times the square root of 4. What's that equal to? Square root of 16, which is what?
4.
4. So what could we have done without going through all that stuff? Square root of 4 times square root of 4 is just what? Is just 4. Or it's the square root of 4. If I multiply it by itself, it's the square root of 4 squared, isn't it? Okay. So what is the square root of 4 squared? It's just 4. So what do I do to a square root in order to get a whole number out of it? I multiply it by itself. Everybody see that? Okay. If I multiply it by itself, that'll make it a whole number. So how do I make this square root of 3 a whole number?
Multiply by itself.
Multiply it by itself. Now, I can't just do that to the bottom.
You gotta do it to
I also have to do it to the top. Now, why? Because what's the square root of 3 over the square root of 3? So 1. And I can multiply anything by 1, correct? Yeah, and it doesn't change the value of it. So am I allowed to do this?
Yeah.
Sure, because all I'm doing is multiplying by a 1 here. But why did I do this? The reason to get rid of not the 3, but get rid of the square root. Get rid of the square root. Now, I'm allowed to have square roots on the top. It's fine. But mathematicians have said that you don't want a square root in the bottom. Okay? So watch what happens here. What's the square root of 3 over times the square root of 3?
Square root of 9.
Which is?
3.
But did you even have to go square root of 9 though?
No.
Because remember, when you take a square root and you multiply it by itself, you're basically squaring the square root, which cancels out the square root. So it's just a 3. Does it make sense? So you're right. You could go square root of 3 times square root of 3 is square root of 9, and then square root of 9 is 3. You could have done that. That's just a wasted step. Now what about right here?
4.
It's a square root of 3 times 12. I'm going to write 12, what? Square root of 3. And this is all equal to x, right? Because that stuff canceled out. But I'm not done. It's not simplified. What do we do to simplify it? It's just basic fraction stuff. I got a 3 on the bottom and a 12 on the top.
4.
Right, divide.
Four
Okay,
square root of
that
3.
goes into this 4 times. Okay, and it's just 4 square root of 3. So that is what the short side is. That's what x is. It's 4 times the square root of 3. So the hard part about this wasn't the geometry, was it?
No,
It was the algebra. Yeah, it was simplifying with the algebra.
I just did
Okay.
because it's like at the very start it was just 12 over the square root of 3. I just divided 12 divided by the square root of 3 and I got 4.
Right, some calculators will give that to you, okay? And that's great. So if you have a calculator that'll do that for you, that's perfectly fine. The old school calculators that I have don't do that, all right? They just give you decimals. They don't give you fractions. But some of the newer calculators, what is it? What's the brand name of that? Hold up real quick. Okay. So let's do one more thing. We still got to do the hypotenuse, okay? So the hypotenuse is how much of the short side?
Double.
It's double. So can you double that in your head? It's this times 2. No, it's not square root of 6.
8.
It's just 8 square root of 3. It's just 8 square root of 3. So that's what the hypotenuse is. All right, your homework is what's on the lesson plan. Did I give you 1 through 16? Is that on the 1 through 10? On 7-4?
Yeah.
Really?
Thank you.
All right, I guess you can just do that. I have 1 through 16 written down on my. All right, we'll do 1 through 10 then. It's fine. So 1 through 10, section 7-4. I still have a little bit more to do, but that's how it goes.